This is the Real Digital Transformation podcast series, empowering technology and business professionals to succeed with digital transformation. Now, here's your host, best-selling author Thomas Earl.
Hi, this is Thomas Earl, and welcome to another episode of the Real Digital Transformation podcast series. I have with me today Kunal Agarwal, the CEO and co-founder of Unravel Data and a leader in data observability. Welcome, Kunal.
Thomas, so good to be here. Thank you.
Thanks for joining us. The topic today is very important in the industry and becoming more and more necessary for everyone to understand. And it's unmasking AI costs and the power of observability for AI. Tell us more about what observability in AI is today, what it means, why it is important, and then I really want to ask you about how that relates to the cost of AI.
Yeah, Thomas, not a day goes by that we don't hear about AI these days, right? Everybody and every company is jumping onto the AI bandwagon, finally, which is a great thing. AI has been around, obviously, for much longer than when ChatGPT came out. But it's a good thing that it's creating this mainstream app that every company and person wants to become a part of. So it's a really, really powerful technology, obviously. ChatGPT and any other LLM models, that is. And companies are starting to even create their own models. So what we see is three different types of use cases broadly. If you think about large language models or AI in general, is you either take a model off the shelf and start using it. You take a model and you tweak it to make it your own, and then you start creating products out of it. Or you go from scratch. You create and train a model all by yourself, from the ground up, and then start deploying it. And as you go from one way to the other, all the way to making your own models, the cost of running AI starts blowing up from a few $1 million to hundreds of millions of dollars to go and create AI models, including LLMs. So that's what I'd love to talk about today. And observability plays a very vital role in a couple of different areas for anything to do with machine learning and AI. And it can help you understand how the models are performing. It can help you understand if the models are actually correct and how correct they are, right from source to application. What your data quality is, and if you've got the right data powering these models, etc. To then also thinking about model performance and the cost of running these different AI models inside the systems that I'd love to shed some light on. And at this point in time where every company wants to become an AI company, this is the right time to start thinking about deploying observability alongside to make sure you're doing things in the right way from the get-go, rather than having those problems, facing expensive cost issues or performance issues, and then trying to fix it in hindsight.
So what exactly are we observing? Is it more the model in production, or is the observability process also there when the model is in training?
Right. So AI models are very, very complex, and you were alluding to some of the stages or the life cycle of this AI model, which is then powered by data pipelines and massive data workloads, and that's what really makes them really, really expensive. And as we were talking about, do you borrow a model? Do you create your own model? It doesn't matter. What most enterprises are struggling with today, as we work with them, is number one, just the escalating cloud data costs in general, and then they have to run fast and generate these business outcomes out of AI. So we see business leaders are caught in this crossfire between this increased demand for this ever more of these petabyte scale data workloads and the financial reality of both budgetary and staff constraints that they have, right? So what we have seen enterprises that have done these things well is to understand, what are the costs, the true costs of running an AI model, and really bringing finance, engineering, and that line of business like product or marketing, etc., together to collaboratively ensure that the organization is realizing the greatest value in the form of its cloud data investments, right? But to really understand the costs, you have to understand some of these hidden costs. And these hidden costs are really about how are you running those data pipelines in each of those different stages of your AI models. And then if you're able to make those hidden costs more efficient, then you can run as much as 50% more workloads without having to increase the budget for running these things, right? So what we see is, the lion's share of this AI model goes into building and running data pipelines. And we see a lot of these data pipelines run on popular systems like Snowflake and Databricks and BigQuery, which is ultimately used for training these models. And for a highly complex AI model, you're looking at probably tens of thousands of these individual jobs and data pipelines. And each of these sub jobs carries a price tag with it, right? So the number one thing that we see successful organizations do is they have visibility of these costs at a very granular level. They're able to understand how much each of these individual pieces of that workflow and jobs actually cost. How much is each data scientist and data engineer spending on each of these individual projects? How much are these applications and data pipelines incurring costs? What are the data storage costs? What are the data manipulation costs, et cetera, et cetera? And without having the visibility first into even understanding where these costs are going into, you cannot tackle this hidden cost and improve that pipeline efficiency at the end of the day.
So let me ask about that. So we're observing the model performance, we're observing the data processing in action at runtime, and the a common approach to working with models, whether you're training them or retraining them once they're out there, is to give them as much data as possible to learn as much as they can and to improve and optimize what they do the best possible. So when we're observing all this happening and we're looking at the costs of achieving that, how do we figure out where to trim back? If we say the cost is too high based on the data we're collecting through observability tools, how do we determine what to cut back? Because aren't we in danger of cutting back perhaps a source of data or a cycle of learning that might impact the quality of the model?
A very good question there. So when we see a monthly cloud bill, we usually find a tremendous amount of self-inflicted overspending. So this is usually the wastages or the inefficiencies that have crept up, even while you're running whatever training that you want to run for your AI models. So this is not about doing 7 tests instead of 10. It's about doing those 10 tests, but making sure that all of those training, testing, and scaling the models endeavors are actually running in a very efficient manner. So what we see is there's a lot of inefficiencies at the infrastructure level, but there's a lot of inefficiencies at the code level and at the runtime level, which, happy to expand on. But what we also see here is as the enterprises are spreading out the use cases of AI throughout various departments and encouraging various departments to run more machine learning and AI models, which is, by the way, a very, very good thing. It also means that more people of varying skill sets are running these AI workloads. And it's not only the hardcore data engineers and data scientists who may know anything about the technologies that they're using, or if they're running in an efficient manner or not, and the underlying cloud infrastructure that's supporting them. These may be, business-focused people who understand the business, but not necessarily all the technology. So when you have such a spectrum of different skilled people, you also have people who don't necessarily have that experience and expertise to make sure that they're running these data pipelines efficiently, and that further accelerates the inefficiencies and wastages inside the environment. Now, when most people think about unnecessary spending and waste, they're thinking about infrastructure. And indeed, you can free up a lot of budget by right-sizing infrastructure correctly, by shutting down idle clusters, by configuring the number, size, and type of resources needed to run a particular piece of that job or data pipeline or that AI model well, no more, no less. But we're also seeing code itself being a big culprit for driving costs up, where you could be able to, write more efficient code, or be able to think about rearranging your stages that you have for your data pipelines to drive more efficiency, to even having reusable pieces in your data pipeline. Maybe the early part of the process where you're gathering and transforming the data can be used by multiple different pipelines and multiple different AI models. So making reusable building blocks. Those are the kind of opportunities that we usually see in terms of driving efficiency that can get you upwards of 40 to 50% savings, to run those AI models. So it's really all across the stack and all throughout, the various layers as you think about your AI models. And that's really what requires companies to, first get a handle on understanding all of these individual pieces, and then being able to triage and understand, hey, where are the opportunities for improvement?
It's really interesting. Could you give us some examples of reusable blocks that you've seen? So, a collection stage or a prep stage or anything along those lines.
Yeah.
Across different AI or machine learning implementations, what kind of reuse potential do you see?
Oh, that's, we see them all sorts of stages and different life cycle components, right? But let me paint you a picture. If you think about data, which is the key asset for any company, that's what you're really using to drive different outcomes. Maybe it is a better marketing campaign. Maybe it is to improve the internal processes of your company, or maybe it's true innovation to create a brand new product. If you look at information about your customers, or information about your sales, or about your marketing attribution, for example, these kind of data sources can be used for multiple different use cases by multiple different teams, as a very simple example. But they all go through that similar machine learning AI lifecycle of exploring those data sets and creating model data sets, which is usually a combination and joining of a lot of these different tables and transforming them into these usable bits of data, which are foundational for, say, I wanted to create a recommendation engine, for example, or I wanted to create a customer 360 to understand what marketing campaigns will a customer react better to, or if I wanted to improve my customer service, so I have all of the information about what products the customer is using, what potential kind of challenges they could be facing, what kind of support tickets have they filed, right? So we usually see these initial building blocks as being a very common place where you can have reusable pieces of just making sure that the data that you have, that and the derivative files and data sets that you create from that raw data are reusable for a variety of different use cases. And then you start to get to the models themselves. There are ways where you can split the inferences of that you're trying to drive from these different model sets into modular pieces as well, which can then become fundamental to go and share in different types of models. So if you're trying to do a correlation analysis between two data sets, sales and customers, weather and sales of a current product, geography and support cases in that geography, for example, right? These can become foundational pieces that then can be leveraged for any of these above use cases for improving customer service or creating a better product or improving your operations or bringing in automation into your different operational pieces that you have inside your company. But to be able to do that, you need to be there's leadership that's required in the companies that's looking at these things holistically and not looking at it in silos. So what we have seen companies who do these things really well is a leader, a group of people inside the leadership team, having a view about what different departments are trying to do with machine learning and AI, and then being the connective tissue to start to think not just vertically but horizontally inside that groups, or what kind of capabilities do we need to create that every team and every project can actually use. And as part of that service, can we provide some of these reusable pieces? And the reusable pieces could be infrastructure, could be data, could be these models that can then help these guys actually catapult their activities from that strong foundation instead of having to build all those pieces out. So it provides them an advantage, and it provides companies an advantage that they're not double, triple, quadruple spending for doing the same things over and over again. So it's more process as well, Thomas, instead of just technology that we're seeing as guiding these things.
That's very insightful. I'm just sort of descrambling in my mind everything you just described. So you have, beyond infrastructure and other supporting resources, from just a AI system perspective, you have a reuse possibility with regards to combining certain data sources in certain ways so that you capture a relationship between data sources, and that processing, and that if there's another model or other models that are developed that require that same relationship, that's one reusable block. You just say, okay,
That's right.
we've already explored the relationship between order history and customer data with this model. If you guys are going to do that too, just reuse that and don't do it over again, and you'll save money. Is that correct?
Correct.
Okay. And then you mentioned that within a model, if I understood correctly, you can break down a model into modular components, each of which might represent an inference or a body of logic that may also be reusable across other models. Is that correct?
That's also correct. Yep. And again, this happens with a horizontal team, right? Who becomes the connective tissue between all these otherwise siloed projects. Because what we're seeing is there are foundational data sets and models which can be used for a vast variety of use cases. So why go redo the things that have already been done by somebody else inside your company? And a lot of times it comes down to just discovery and understanding what other teams and your colleagues might be doing in the other building in the same organization.
How does it look like when you capture a data source relationship? I'll call it that for lack of a better term, as a reusable block. When you capture a subset of a model, a body of logic within a model as a reusable block, how is that physically shared? Is there a repository or is there a library that you can organize that into to make it available to other project teams?
Right. So lots of different ways. What we traditionally see, Thomas, is companies have a data lake in addition to their data warehouse, along with information about any sort of metadata, through data governance policies, obviously, whether you're allowed to share it or not within these kind of organizations. And those things become highly shareable on a cloud infrastructure environment. What we help out with is also driving efficiencies of code and efficiency of data storage or data access that companies may otherwise be misusing or creating or creeping wastage into it, right? So that's how you would do this. Do the sharing of those data repositories and those models is through having a data lake that allows you through data governance to be able to share those repositories between different groups and individuals inside your organization. We're also seeing companies create data marts to be able to share information and such data sets outside of their organization. We have telecom providers sharing data with banks and vice versa. Car companies which are trying to do connected car projects and self-driving cars, for example, share data with companies that either send signals through sensors, or companies that are creating these driverless systems with the car companies like GM and Ford, for example. So there are starting to become these established set of best practices to be able to share any sort of data models between organizations or even internally within an organization.
So how widely is this currently being adopted? Is it an emerging practice, or has it become a common practice in within organizations that are already active with machine learning and AI? Is there common awareness of this, or is this something that organizations still need to learn?
They still need to learn, unfortunately. But look, if there's a lot of shareable components within AI, and I think LLMs have paved the way for making things more shareable and making things more foundational that you can start to build on top of. So if you can have a model that is open source, then why can't you have data sets and data algorithms and inferences and models outside of just LLMs that could be shareable as well? So the industry should start moving towards that place for sure. But yeah, unfortunately, it's in the early innings right now.
And all of this would fall under governance.
That's
the
correct.
Governance of what you put in place, the regulation and the way
correct,
you
correct.
manage
And people are figuring out exactly how do you govern your data, what are the IP rights for your data, what kind of metadata practices should you have. So some of these things are organizational related, and some of these things need to be sorted at a larger national level itself to figure out what's right or wrong while all these rules and rights are being written as we speak.
Mm-hmm. You mentioned LLMs a number of times. So from an AI observability perspective, how is it different applying an observability framework to a generative AI environment compared to a traditional predictive AI environment? Are you observing different things? Are you fine-tuning different things as a result of the observations, or is it more or less the same?
Yeah, so let's put our lens of cost in this, because how you observe what you observe and the analysis that you're doing for it ultimately comes down to what kind of use case are you trying to solve. So what we do, so first and foremost for us, when we think about improving cost across your AI pipelines and then the models, it's pretty much the same. Doesn't matter if you're using LLMs or any sort of other AI model. If you are using an off-the-shelf LLM, say ChatGPT, for example, then you have to monitor a few more new elements like tokens, which could then rack up to becoming a huge amount of money for your organization as well, right? But at the very core of it is really getting lots of telemetry data about all of these different pieces that make up your AI stack and then make up your AI model pipeline. These come in the forms of logs, traces, metrics, events, and it's kind of like a big data problem to solve, even on the observability side. It's pretty similar in that you're trying to solve problems on a complex stack, so it's not really solvable by a human, because if they tried to do it, it would otherwise take too much time to go and resolve that issue, or you would miss out on some of the areas that could have caused the issue. So it's not going to be comprehensive. It's the same way that companies think about their customer data or their marketing apps, right? It is give me the insights rather than drowning me in all these metrics and then having me figure out the correlation between these different pieces and the why behind certain things. So we treat our data the same way as the companies using these data for the AI models treat their data. Only difference is our data is telemetry data and metadata information about the systems and these applications itself. So we measure everything, Thomas. That's like the number one rule. Measure all, and when I say measure all, it's both horizontally and vertically. So look at every layer of the app from top to bottom, from your application code all the way down to the bits and bytes that it's actually running on, and then left to right. From data source, how is this data generated? How is this data stored? How is this data manipulated? All the way to how this data enters data models and the outcomes that it has in different applications. And once you have that information, you start to understand what is happening. At any given point of time, you can start to see things about this model A is working. It's running in so much time. It's generating these kind of outputs. It's running on this kind of infrastructure. It's incurring so much cost. But what you don't understand from there is why something is happening. So say something was misfiring, or something was more expensive, or something was slow. And then how do you go and resolve that? And that's where we employ AI techniques ourselves. At the bare minimum, first we start off with correlation to start to think about what are some of these different metrics and different values that actually correlate with each other, and then can we deploy algorithms to go and figure out all these common problems that happen within an environment. Can we spot them using code and then validate that indeed is the problem, and then guide the user to a remedy, or even better, solve that problem ourselves. And this has been a game changer for companies, because a lot of these data team folks are already pressed for time, and they already have these big projects that they need to go and deliver on. And what we see is they're actually spending more than half their time firefighting issues. So if we can take that, the toil away from them, and give them a guarantee of quality on the service, and to the business, highly efficient, AI infrastructure and applications on top of it, that they don't need to have to worry about that. All they can focus on is getting these amazing insights from these data endeavors that these guys are doing. So we have also designed our system as ultimately an AI system.
So these problems you mentioned, these are problems identified by observations.
Correct.
And the AI involvement you just described, if I understood correctly, it's that you have there's a tool that collects all of this data from the observability monitoring, and then you actually use an AI tool to make sense of all that data, to highlight and better define the primary problem areas.
That's correct. So we've developed our own algorithms. So we use data analytics techniques, we use machine learning, we use AI to solve different classes of problems. but you're absolutely correct. Number one is to understand why something is happening, what's causing that problem. You may find a symptom manifesting itself because of 6 possible things that could have gone wrong, and then being able to narrow down and say, hey, it's not these things, it's this one piece that's actually causing your problem at this time today. So then you can confidently take an action on resolving that. And where we use AI is to automate the resolution. And in some cases where automation is either not possible or not recommended, where it would be, a fork in the road and you have 2 ways to solve a problem and you pick your path. You want to go this way to solve this problem or that way to solve this problem. We would present the user with those options. But the ultimate goal of doing all of this is to simplify this rather complex, hairy AI beast for these end users. So when they have a challenge around things that aren't working, things are slow, they go from the current model of, let me file a ticket, let me get the support team on it, let me get all these logs and metrics, let me then break it apart and analyze it with a bunch of other people, to then the future state, which is if I have a problem, here comes an assistant that tells me in plain English, this is what happened. This is what you need to do to go ahead and fix it. And if you want me to fix it, I can do that for you as well. So that goes from hours and hours and hours of manual digging in and trial and error to a simple click.
Super. One last question, Kunal. You mentioned before that observability tools measure everything possible, everything relevant. Based on your experience with these environments and the results they've produced, what are your top 3 or top 5 measurements that you would recommend organizations pay the most attention to, or those that have made the most difference in terms of acting on either trends, good or bad, problems, or other types of anomalies, whatever they may have discovered? What are the top 3 things organizations should be measuring?
Yeah, it's rather simple, Thomas. It's measuring the unit costs is the most important piece. So you really have to break down your entire complex AI pipeline and models to individual stages and jobs and start to monitor at that level. If you have that kind of visibility, then you can understand everything. Meaning, tomorrow your company is going to stop going from exploration phase to actually trying to generate revenue from AI. And somebody inside the company is going to ask you, what is the ROI of getting this AI model in production? You need unit cost for that. You're trying to solve another use case of, hey, I need to reduce my expense on AI by 25%. You need to be able to understand where those costs are excessive, and only then you can go and firefight those cost issues. So you need to understand, again, at the unit level of what's going on. If you need to understand which of your users or departments are costing the most, and if they are being efficient in how they're running those pieces, again, you'd have to come down to the unit cost. So if there was one thing, one takeaway on observability when you think about AI workloads, is break them down into individual chunks and really measure from the ground up. Don't take a tops down approach, but take a bottoms up approach.
Okay, and from a runtime measurement perspective, in terms of performance or runtime issues, what would you say is the top metric or measurement you're looking for?
Oh yeah, absolutely. So when you think about cost, those are some of the areas to focus on. When you think about robustness, reliability, and performance, you have to really think about them together. Because an application that's not working, obviously bad. An application that's slow, equally bad, because you may need to generate some real-time results. So uptime and latency and throughput, these would be the 3 metrics that you're really looking at. So is your app working, not working? Red light, green light. And how often is that happening? over a period of time, a day, a week, a month. So you're thinking about, uptime. The other one is latency, and the latency of the individual components of your app, and then the latency of this app, if you can call it an app, end to end, because both are important. And if you don't understand, again, that individual component, then you don't know where the bottlenecks are. And if you need to improve the latency of this entire application, then you wouldn't know where to start looking, because it can be in one of those thousands of different stages. And then the throughput, which is the tying metric between efficiency and performance, and it's a cost performance trade-off, really, is how many times in a given period of time can that job be performed over and over again. It could be a model, it could be a piece of the model, but the more throughput you can get, what you're really doing is decreasing the cost of individual runs of that data pipeline and that model in one time. So those would be the three metrics that should be the high key level KPIs that should be flashing on your dashboards as you're running these AI models all the time.
Super. Very, very interesting. And I think will only increase in importance as we all collectively do more and more work with AI and rely more on what it gives us. Kunal, thank you for joining me. Before we conclude, please tell me more about what you do at Unravel Data and what Unravel Data is about.
Thank you, Thomas. It's a great, sitting down here and chatting with you. So a little bit about the company. Unravel Data is a leader in data observability and data FinOps. I'm the co-founder and CEO of the company. We started this company when Shivnath and I, my co-founder, and I were at Duke University. And we had seen companies struggle with making their data projects highly performant and, making sure that they can get reliability out of it and they can actually depend on it. So we embarked on this journey of changing observability from being a just show me what's going on to helping customers actually solve problems with it. So our mantra is to go away from graphs and metrics to answers. And if we can provide those answers in the minimum amount of time and in the most simplest way that it becomes actionable for our customers, then we will achieve our vision. So we've been on that journey. Unravel works across all the major popular data platforms on different clouds. Companies of different sizes and industries use Unravel today to make sure that those data pipelines and AI applications are running properly, they're scaling properly. But more important is that the data engineers and the data teams have less frustration. They're actually productive doing, these groundbreaking things with data. And that's what really excites us.
Super. Kunal, thank you so much for your time today. I look forward to another opportunity for us to dig a bit deeper into AI governance, observability, and other topics.
Thank you, Thomas.
Thank you for listening. Follow Thomas on LinkedIn